Now see this uniform random variable. Let capital X is a random variable. Okay, so first of all you understand what is meant by uniform. So this one is one of the types of continuous random variable, which means we are going to have, or this particular random variable is going to take on a set of uncountable values. So it is not going to be a countable set, it can take uncountable values, that is for sure. And the second thing is it is uniform, which means if you see the this probability density function, it is going to look like a straight line. It is going to be uniform forever, right, or wherever it is defined. Now see this, capital X is a uniform random variable on the interval alpha comma beta if its probability density function is given by f of x equal to 1 by beta minus alpha if alpha is less than beta, alpha is less than x less than beta. So what they mean by this one is, if you see the uniform this probability density function, let us say this is alpha and this is beta, and this particular value is 1 by alpha beta minus alpha. Okay, and now our random variable will be 0 till this part, and between alpha and beta our random variable will take uniform, which means it will continuously be 1 by beta minus alpha. So between these 2 points it will be uniform, and for all the other points it is 0. Got it? So then such a random variable is called uniform random variable. Remember, we are going to classify the random variables based on what is its probability density function or what is the probability mass function in case it is a discrete random variable. In case of continuous random variable, we'll just see what is its probability density function, and then we decide whether it is uniform or some other type. Got it? Now why is the name uniform given? If you observe it, see this one, it is exactly uniform here, right? It is not changing, and in the other part it is changing. Got it? And now how to find out the probability of a particular interval in this particular interval alpha comma beta? Just see that one, or let's see whether it is for satisfying that property that the sum of everything is going to be 1. So if you try to find out the entire probability of this random variable from minus infinity to infinity, anyway from minus infinity to this one, so how to find out the probability? There are actually 3 periods here. One period is minus infinity to alpha, and other period is alpha to beta, and the other period is beta to infinity. So we have these 3 periods defined, or these we can divide this entire total period from minus infinity to infinity into these 3 periods. Now let's try to find out what will be the probability in each of these areas. From minus infinity to alpha, the probability given is 0, which means for this part the probability is 0. From alpha to beta, the total probability of this random variable is going to be this area. Now what is the area? If you look at it, it's looking like some kind of rectangle, isn't it? And for this rectangle, clearly the height is 1 by beta minus alpha, and the breadth is beta minus alpha. So we know that for a rectangle the area is equal to length into breadth. So which means if you have to multiply these two, so length is 1 by beta minus alpha, and then breadth is beta minus alpha, and for this one it is 0 again, because after beta it is not defined, it is given as 0, right? It is defined and it is given as 0. See this, for only between alpha and beta the value is 1 by beta minus alpha, for all the other values it is actually 0. Therefore if you see this, if you sum all these terms, this one is going to be 1, this probability is 1. Or if you want to see it from other way, using this formula itself, now I told you that from minus infinity to infinity f of x dx has to be always equal to 1, right? Now let's see if it is true or not here. So I can write it as if it is from minus infinity to alpha f of x dx plus alpha to beta f of x dx plus beta to infinity f of x dx. Now this one is 0. Why? Because from minus infinity to alpha it falls in this case, it is given as 0, and also this one is 0 because from beta to alpha it falls again in otherwise, which means 0. And for this part the integration is going to be alpha to beta 1 by beta minus alpha dx, and this is it is a constant which is independent of x, so we can get it outside the integration. So what do we get? 1 by beta minus alpha to beta dx. What does it mean? It is x, alpha to beta minus alpha, which is nothing but beta minus alpha by beta minus alpha, upper bound minus lower bound, right? Beta minus alpha, which is again 1, so it is 1. So that is the meaning of it. So why do we choose exactly 1 by beta minus alpha is we have chosen this particular value so that this particular rule will be satisfied. What is the rule? Sum of all probabilities should always be equal to 1. For that particular rule we are going to use it. Why is it called uniform? Is in this particular range it is continuously the same value. Why only this particular value? Because if I take that particular value, then only I'll get this sum as 1. If I take any other value, this sum will not be 1. That is why this particular value. Now if you want to define a uniform random variable between the range 2, 4, then what should you do? See this, from 2 to 4 if you want to define, right? Now you have to find out what is 4 minus 2, which is 1 minus 4 minus 2, you have to find it out. So which is nothing but 1 by 2, which is 0.5, right? Therefore between this range you see that the value of f of x is 0.5. So let us say this is 0.5. Then for this range we are going to have this, and for the remaining we are going to have 0. Therefore even if you apply the total probability this like this, you are going to get 1 as the output. Therefore if you want to define a new random variable between uniform continuous random variable between 2 and 4, then you should have f of x equal to 1 by 4 minus 2 for the range 2 less than x less than 4 and 0 otherwise, right? And so you will get a function looking like this, and even if you try to find out the total probability, you are going to end up getting 1. Got it? So this is how uniform random variable is actually defined. So let's see some problems on it, you will understand better.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.